Hello everyone, welcome back to my channel. So today we are going to do Leetcode daily challenge longest string chain. Basically it's a long time that I hadn't made any video regarding Leetcode daily challenges. But yeah, now I'm trying to be starting again. So here's the first video for the same. This question was basically one of the not was but it is one of the variation of LIS when I was in my college, but at that time only I had done all the standard types of the DP which are there, and one of them was this one. But today we won't be going ahead with that format. We will be making it more optimized. So let us go ahead and first read this question, then about the constraint, and then example. And from those example only, I'll explain you that how that thing we can do so that it is a more optimized solution. Basically, this is homework on you that how you will be doing with the help of LIS. So now let us read this question. You are given an array of words where each word consists of lowercase English letters and word A is predecessor of word B if and only if B can insert exactly one letter anywhere in word A without changing the order of the other characters to make it equal to word B. And then, for example, ABC is predecessor of ABAC. So here the thing is that ABC is predecessor of this ABAC because here now the words order has been changed. You can clearly see before B there is A and before C there is B, right? And we have inserted this A in between that. So basically all the word characters which are there, they are in same order only. So that's why ABC is predecessor of this word. But here CBA, it is not predecessor of this because here you can clearly see that here C is coming before B, but here B is coming before C, right? So that's why here CBA is not the predecessor of BCAD. So now a word chain is sequence of words, word 1, word 2, up till word K, with K greater than equal to 1, where word 1 is the predecessor of word 2 and word 2 is predecessor of word 3 and so on. And a single word is trivially a word chain with K equals to 1. So now what we are required to do in this question is that return the length of the longest possible word chain. Basically not the longest possible word, but the longest possible word chain with words chosen from the given list of words. So now here these three examples are, but before that let us check the constraint. So constraint here we can see that length of the word is up to 1000 only and to and the character basically this words dot length means this one which is there. So total number of words which would be present inside that is up to 1000 only, and each word which is inside there, its length could be only up to 16. So basically the constraint which are here, they are in that manner that we can easily go ahead with our DP solution. Means if we go ahead with, if we take this as n and if we take this as L, then here L square into n, if it is done, then that would be easily able to go ahead. And if we do something like n square, here 10 raised to power 3 is there, right? If it becomes 10 raised to power 6, then surely it will give us TLE. But here we can easily go ahead with 16 into 16 into 1000. So that type of time complexity, it will suffice. Now the thing is that how we are required to do this question, we'll go ahead with these examples and then we will go ahead with the coding part for, coding part for the same. So uh, here. So in the first example which was given here, A is given, right? So if we go ahead, A, and if we insert any character before or after, say here BA, because B is already present in this, right? Then in this BA, we either need to insert in between or before B or after A. So here we inserted in between C. So BCA becomes, and it is already present here. And then we need to keep the order same and insert any character here, here, or anywhere. So we inserted D. So basically the longest word chain which is formed, it is of 4 words. Then if we choose this B, now here B and add one any of the character that now here BA which is present here, then BCA and then BDCA again. This is also a word chain of length 4. Now in this examples, I guess till now you would have been clear somehow that how the things are ongoing. So now here XDC which is there and then XB the smallest one that is the XB. Now we add one character C, then we add one more character and then we add one more character and then we add one more character. All the ordering of the characters relative to each other is already same. So that's why we are adding up the words into the same and then it becomes the longest word chain with total words as 5. Then here in the third example which is there, here ABCD and DBQCA which is there. So now here in DBQCA, here the characters basically are in different order as compared to ABCD. So that's why here the word chain is at max of one length. This is the that thing which they have mentioned in this question. This thing that if uh, a single word is trivially a word chain with k is equals to 1. Because here the thing was that here word chain was not possible, right? So that's why our output is 1 with the word as only 1. So now the thing is that we can easily go ahead with LIS solution for the same, where because we can clearly see here it is all about the sequences only, right? But that will become a solution which will be having some means more time complexity, but the space complexity of what we are going to go ahead today would be same as that of LIS solution only. So now here what we are going to do is we will be doing with DFS plus DP solution. DFS would be for finding the next word which is there and the DP solution would be for storing of all these words which are there. Now the thing is that here I have explained you from smaller to the longest, right? But now in our solution we are required to go ahead with any of the word which is there and we are required to check for whatever new word could be created out of that by the chunks of these words and adding up means basically appending them with each other and then going ahead and finding that word in this word basically vector of string which is given to us. So let us go ahead for coding this particular question. So here, as I told you that this would be a DP plus DFS solution. So for that purpose, now let us go ahead. We would be required with 2 data structures. Basically, one would be our unordered map, where we will be storing that what is exactly till now the count of the words which we have stored because of that final word. So for that purpose, we would be having one unordered map here, and that would be the word and its count. So that's why we will be naming it as counts. Now one more unordered. Now this won't be a map. Now we are required with unordered set. So this unordered set is basically for the purpose of easy lookup. Is rather than we would be taking from our this the input, we'll rather store in this particular words present in our question. So now the first thing would be that we will whatever words which are there, we will be storing them in our unordered map so that we can easily do a lookup while we are doing DFS. So here the thing would be words present dot insert whatever word you've taken from there. So by this we have filled our unordered map. Now here we will making our answer as 0. Just initializing that answer. Now here comes the part. Now we will be going ahead with that DFS part. So we will be taking one by one word which is there from our words, and then here we will be checking that what is the maximum count till now for the words which is there, and this we will be going ahead with our DFS function. So first we will be going ahead whatever words which are present so that we can do easily lookup. And this is what we are passing that till now this was the maximum count till that word, and this would be the present word for which we will be making various combinations so that we can go ahead and check that yeah, that was the thing. And here at the end, after all these things are done, then we are good to go with our answer. Now comes the part that we need to form as this particular. So now the thing would be that first thing is that in our DFS, as we are required to return the count, so return type would be in, and then first is already our unordered set. Whatever words are there, and then unordered map which is there, and then our present word which is there that we are required to go ahead with. Rather than word, let us take it as current word only. It is much more easier for us that this is that current word. Now comes the part for our DFS thing. The first thing would be that if we already populated with that particular count of that word, then we will directly returning that count. So this would be the first thing which we will be doing. As I've already told that this is a combination of DP and DFS solution. So the thing in the memorization part of DP we do when we are going ahead with top-down DP. So in that context only we do this thing. So here we will be returning whatever. Now comes the next part. So we will be at each moment counting that what is the maximum length. Maximum length, as in the question it was mentioned, it will be always one for a particular one word, right? But here we are required to count that what would be the maximum length of that word chain which could be formed, right? So now let us go with that logic. So here the main part which we are doing here is that we are starting, we are basically going ahead that whatever length of that particular word is there, word dot length. And now the thing would be what we are doing is that we would be skipping each character in the same so that we can form various combination of that particular word which is there and go ahead with if that word is really present or not. Subster 0 comma I, and then current word dot I plus 1. So because of this we will be easily able to, so the next, right, now we would be having a new word because of this. Now comes the part, the new word which is formed. Now we need to find that new word in the words which is there. So if words dot count new word, it is missing. Okay. Then the current length we need to figure out. Current length equals to 1 plus the one. If that new word is present, right? So that one would be added to that, right? And then next we are required to figure out what next word could be found in that chain. So because of that only, we will be calling out our DFS again with the same thing which we were having earlier also. And then after that maximum length which is there, maximum length would be maximum of our previous length which was there. If that was maximum, it's fine. Is the new length which we have formed, if that is maximum, so that would be there. So this is the thing which we will be doing continuously and calling out our DFS again and again. And then when this for loop would end, so now after that, we are required to fill that particular current word which was there with the maximum length being obtained till now. So this would be the thing which we are required to do here. And when this thing is completed, and then at the end, we will be returning that maximum length. Because at the end, we are required to return the maximum length obtained till now, right? And why we are filling this is so that if again that particular word is there, so we can easily exit out by this condition. So that is the thing. So after doing all this, now we are good to go ahead. Now comes, hmm, let me show you this. Okay. Hmm, if any other violations will be there. Okay, honest. So this is the thing there. Now let me show you that what is the time complexity and space complexity for the same. So as I told you, here this particular new word which is there, right? Basically, sorry, here what we are doing is this is the loop of order of n, right? And this is again the loop of order of n, right? And here the thing which we are doing, here the DFS which is being done. Now in this DFS, what we are doing is we are basically going ahead upon the length of that particular word. If we take the length of that word as L, right? So here this loop would be of L, and then again as we are going ahead with doing DFS into the same, right? And here again and again. So this for loop would be running it as that part, and here because of this DFS which we are going ahead, then this DFS will again go ahead with the order of L times only. So that's why this will become L into L. So basically the whole time complexity of the solution will become order of N into L plus order of N. So this would be the whole time complexity. And now comes the part for the space complexity. So here we are taking this unordered map where there would be string and those total string would be this one only, and here also total string would be this one only. So basically The space complexity which we have used would be order of n plus n, and there would be one more space complexity that would be of stack, right? And that will also go up to order of n only because of this DFS going uh, as per the word length. But yeah, word length, and that would be of order of L. So basically, that would be of order of L. So now the time complexity and space complexity for this solution is this one. And yeah, let me come with the solution. So this was all for this particular question, and this also got accepted. You can see that. So if you have any doubt about this question, you could comment that down. I would be happy to help in the comments which we provided. And yeah, if you have not subscribed to my channel, do subscribe. And if you really like the explanation, do like this video. And yeah, if you know anyone who is also doing lead code, we say consistently, and you can share this video with them also. So this was all. Thank you.